Hello, so in today's video, we're going to look at some key identities or key results that will be useful in A-level maths. So yeah, we're just going to go through these key results and kind of justify why these results are true. But I mean, the first one actually should be quite familiar with you. So this is just the difference of two squares. So x squared minus y squared is the same as x plus y times x minus y. Again, this is just from GCSE maths, from school maths. This is just the difference of two squares because obviously when you expand the brackets, you do get the desired result on the left-hand side. So we'll just skip this one, to be honest. But this next one, this second one, may be a little bit new to you. So x cubed minus y cubed is equal to x minus y times x squared plus xy plus y squared. Okay, I mean, you can either just learn that result here and you can just learn all of these if you want to. But we can actually try and justify why that's the case. So let's think about this one. So what I'm going to actually do is I'm going to call this x cubed minus y cubed a function. I'm going to call it f of x. So f of x equals x cubed minus y cubed. I'm just going to specify that y is a fixed number. So it's a fixed real number, so it's not a variable. Okay, so we've got a function of x, and this is the function. Well, what happens if you substitute x equals y into the function? So if you substitute x equals y, so you get f of y is equal to y cubed minus y cubed. Well, that's just 0. So now we can think about the factor theorem. So f of y equals 0. So therefore the factor theorem, tells us that x subtract the negative of that value there. So just subtract that value there. So x subtract this value is a factor of f of x. So it is a factor of f of x. So therefore we know that x cubed minus y cubed is equal to x minus y, and then times by some other factor that we don't know yet. So to get this other factor that we don't know, I mean, I've obviously already given the answer away. But what we can actually do is we can just kind of guess what would go in there. We could also use the long division method as well, what we did in the like what we did in the previous video, where we did something like this. We put the x minus y on the outside there, use this like bus stop method. So x cubed minus y cubed. And then you can say, okay, well, how many x is going to x cubed? Well, that's just x squared. And then you can do x squared multiplied by this divisor there. So you do subtract x cubed minus yx squared. And then you can subtract that. And if you subtract everything there, you'll be left with a positive yx squared. Negative yx squared is positive yx squared. And then this negative y cubed that's carried over. So negative y cubed there. And then you can repeat the process again. And then you can say, well, how many x is going to yx squared? And then you would get a positive xy. And then again, you can multiply xy by this divisor there, subtract it from our result down here. So you would end up with yx squared subtracts the x y squared from that times that. I'm going to stop there because if you just carry on, you will get the result. But you can also just guess or kind of use inspection to work out what's going to go in there. So, I mean, we know we need to make an x cubed, and we know that x times x squared gives us x cubed. So it's logical to put an x squared in there because x squared times x is x cubed. And again, it's logical to put a minus y squared over there because, sorry, a positive y squared, my bad, positive y squared, because positive y squared times negative y gives us the negative y cubed that we need. So we know for a fact that we can have an x squared and y squared there. So to determine what goes in the middle, we just got to think, okay, well, if we multiply x by y squared, we get xy squared. So we need to get a minus xy squared somehow. And we need to get a positive y x squared somehow because we've got this extra minus y x squared there. So if we actually do put the xy in there, as we can see from, well, we can tell from up there, we will get the result that we want because when we put that in, we get, I'll do this in red, we get minus y times xy, which gives us minus xy squared. Well, guess what? This now cancels out with that. And then if we do that times that, the x times the xy, we get x squared y. Well, guess what? That cancels out with that there. So actually, yes, this does work. And so therefore, we get a final factorization of x cubed minus y cubed is equal to x minus y times by x squared plus xy plus y squared. So yeah, we can use the factor theorem to basically justify why that is true. So just as like a little example to kind of exemplify what we're doing here. So yeah, a good example, I guess, could be something like this. For example, so let's say you've got 8x cubed minus, let's go with 27 a cubed. So to factorize this is just going to be the cube root of that number there, subtract the cube root of that number there in our first brackets. So 2x subtract 3a, and then multiplied by x squared. So if x is, so if our analog of x in this case there is I've circled the wrong things. If our analog there of x is 2x there, then 2x squared is going to be 4x squared. So we get a 4x squared there. Minus y, our minus y there corresponds with this minus 3a there. So minus 3a all squared is going to give us a 9a squared at the end there. And then, okay, so x times y in the middle. So that would be our x value. So let me just do this in red to emphasize this. So this would be our x. This would be our y. So x times y is going to give us a negative 6xa. So in the brackets here, we get negative 6xa. And that would be our factorization. So we can actually use this to factorize harder examples like this there. Okay, great. So that's that one. Similarly with this third one here, this is very similar. So if you've got x cubed plus y cubed, again, to justify why this identity works, we can just call this f of x again. So we know that if we substitute negative y into x, what we get is negative y all cubed plus y cubed. Now, negative y times negative y times negative y is actually negative y cubed itself. So negative y cubed plus a y cubed, well, this just gives us 0, so that just cancels out. So again, we can use the factor theorem. So therefore, factor theorem tells us that x minus that number there, sorry, minus y, minus the number there, is going to give us x plus y. So x plus y is a factor of f of x. Okay, so we know that. So therefore, again, x cubed plus y cubed is equal to x plus y multiplied by some factor that we don't know. Again, we can just guess the numbers. So x times x squared gives us x cubed. So let's just put an x squared there because that makes sense. It also makes sense to put a plus y squared there because y times y squared gives us y cubed. And again, it makes sense to put a negative xy there. Again, you can use long division to prove that, but you will have a negative xy there because x times negative xy will give us negative x squared y. But y times x squared there gives us positive x squared y, so they cancel out. And the same thing with the next lot of expansion. So y times x squared, well, that's just yx squared. But we get y times negative xy there, so negative x, x squared. Sorry, I've done this the wrong way around. It should be, it should be this one here. So oh no, wait, sorry, I've done that the wrong way around again. So it should be, yeah, so it should definitely be this one there. So you get a negative x squared y, but yeah, that cancels out with that. So everything cancels out. So we're just left with the x cubed plus y cubed. So yeah, so we know that that factorization as well works there. So again, we can conclude from that that x cubed plus y cubed is equal to x plus y times x squared minus xy plus y squared. So again, it's just like an example to exemplify this. So let's say we want to factorize. So factorize. Again, let's go with something like 64x cubed plus, let's just say, I don't know, let's just say 8a cubed. Okay, so again, our x value, so using the formula here, so our x value would be basically the cube root of that number there. So the cube root of this there will be 4x. So our x value is going to be 4x. I'll use an arrow instead of an equal sign there just to make it clear that we're doing like a transformation. And then our y, so our y value, our old y value there is going to be the cube root of this 8a cubed. So this goes to 2a. So using our formula, x plus y, so that's going to be 4x plus 2a. And then x squared will be 4x squared, so that's going to be a 4x squared in there. Our y squared will be 2a squared, sorry, 2a all squared, so basically 4a squared. And then the middle, so minus 4x times by 2a, because x goes to 4x and y goes to 2a, so negative 8ax. So that would be our final factorization. Yeah, I mean, we could actually factorize even further because we do have a factor of 8 that goes into both those numbers there anyway. So we could have actually factored out the 8 to start with. So that would give us an 8x cubed inside the brackets. Sorry, 8x cubed, and then plus an a cubed there. So actually, if we factorize using the formula with that, with this factor there, we would just get 8 multiplied by 2x plus a, and then times by 2x squared, sorry, 2x, yeah, 4x squared, I should say, 4x squared, and then over there would be the a squared, and then a times by 2x, so a plus, sorry, negative 2ax in there. So this result there is actually just the same as this result there. And you can kind of see that by bringing out a 2 from this factor there, which gets you that factor there. And then if you bring out a 4 from the factor over there, and from the factor there, and from there, then you'll get the result from there as well. So yeah, so apologies. Yeah, I've noticed a mistake with this there. That's why I was umming and ahhing. That should be 16 there. Sorry, because 4x all squared gives you 16x squared. So that's why I made a mistake here. Yeah, so that should be a 16x squared there. So when you factor out a 4 from this factor there, and when you factor out a 2 from there, 2 times 4 gives you 8. So yeah, you do get this result here as well. So 8 times 2x plus a times by 4x squared minus 2ax plus a squared. So that'll be our final factorization. So yeah, again, you can apply the formula with these kind of examples. So that's our third one done. And then our last one, so x to the 4 minus y to the 4. So this is just an application really of the difference of two squares. So x to the 4 minus y to the 4. Well, that's just the same as x squared plus y squared times by x squared minus y squared. So again, this is just an application of the difference of two squares. So difference of two squares. And so again, we can actually use the difference of two squares there. So we're going to be left with x squared plus y squared times by x plus y times by x minus y. And so we get that result there. Again, we can use this formula to factorize examples like we did with the previous two. So yeah, it's just a case of realizing that we can use these four formulas or identities to simplify expressions if we need to. And again, apologies for this example here. Again, when you do x squared with this example, 4x squared gives you 16x squared. So that should have been a 16x squared there. Apologies for that. So yeah, you can use again these identities when you want to simplify expressions. Any questions, do leave them in the comment section to the video.